All right, so we're going to go ahead and head into chapter 4 here. This is a little bit shorter than the last chapter, but it's just as important. I know these first chapters can be a bit grueling, but I want you to spend as much time as you possibly can in this content because this is going to be sort of the foundation of everything that we do moving forward. You're going to need to know how to do decision structures. You're going to need to know how to do repetition structures. You're going to need to understand assignment operations, variables, input, output, all those sorts of things. So I hope you're following along in your ID, making sure you're writing all these code. And again, if you're having any troubles, please email me, get a hold of me ASAP so we can figure something out. So we're going to head into chapter 4 here. In chapter 4, again, we're going to be covering an introduction to repetition structures. We have a while loop and we have a for loop that we're going to talk about. These are count-controlled loops. We also have an accumulator that we're going to be talking about, which is a running total. We have sentinels, which sort of determine whether or not something stops or starts or whatever. We also have input validation loops, nested loops, and we're going to ignore the turtle graphics stuff. All right, so the introduction here to repetition structures, there are times in a program where you just need to loop a few times, right? And it may be that you want to loop 10 times. It may be you want to loop 15 times. It may be you want to loop some user-defined amount of times. Sometimes you may want to loop until the input is some value, right? But there are so many times in code where you just have to loop, especially in terms of data processing, right? So if we have a data set, the data set has 255 records, okay? It would be really, really good to be able to start at the beginning of that data set and to iterate through every single one of those records and then search those records for some given thing, right? So that means that we can get the size of that data set and then just loop through the entire data set. And the same thing would be for a string. The same thing could be for input. There are a million different reasons why we would actually do this repetition. Now, the thing is, without some sort of a looping functionality, for instance, we would have to, for that 250 entry data set, we would actually have to just write 250 lines of code that grabs the data out of that particular entry and then looks at it, right? So that's 250 extra lines of code that we don't need to do that. With a loop structure, we can actually just loop it using about two lines of code, roughly, which is nice because if we're talking about big data in particular, where we have maybe a million different data points, we don't want to have to write a million different lines of code just to be able to search through that data set. So instead, we use things called repetition structures. Now, this can be demonstrated in, say, sorting through laundry, for instance. A repetition structure would say, okay, here's the laundry basket. How many items are in the laundry basket? Let's say there is 25. All right, so for, and actually we could use a while loop. Let's say a while loop is better. While laundry basket is not empty. Okay, so we just talked about logic, right? So while laundry basket not empty, we are going to grab a piece of laundry and we're going to say, is this a sock? And if it's yes, then we put it in a pile. Otherwise, we put it in a different pile. And we're going to go through the entire contents. We're going to loop through the entire contents of the laundry basket until we have pulled out all the socks. Okay, so that's another reason why we would want to sort of, in a real life, we would do some sort of a repetition. Repetition's everywhere. We do repetition all over the place in sort of our everyday lives, and then it's no stranger in programming. So again, oftentimes we have to write this code that does the same thing over and over again. So again, 250 lines or 250 entries in a data set, we'd have to write 250 lines checking each line separately, right? And again, the disadvantages, there's three primary disadvantages to duplicating that code is it makes the program huge, right? It's time consuming. And what happens is, let's say I wrote those 250 lines of code and there's one error in all of them, right? I have to spend a ton of time correcting things. It'd be really nice if I could just use the same code over and over and over and over and over and over again, right? It's sort of like a function, like input or print. It's nice to just reuse the code, right? And so I only have to write the code once, and I only have to test the code once. And I only have to correct the code in one place, okay? So we could do this in terms of looping and stuff like that with something called a repetition structure. And this repetition structure makes a computer repeat included code as necessary. Okay, so again, we have condition controlled and we have count controlled loops. So initially, we're going to talk here about this while loop. Now, while loop is pretty logical, right? So you can break this down into English language. While a condition is true, continue to loop. Okay, so while condition is true, do something. When it's false, stop. Okay, so, while number of balls in basket is greater than 50, get rid of a ball. And so obviously you pull a ball out it's, 52, you pull a ball out, it's 51, you pull a ball out, boom, it's 50, so we stop iterating. Okay, so while the condition is true, do something. Again, it has two parts, obviously. You have the condition to be tested, right? So while, number of balls is greater than 50. And then you have the statement, which is sort of repeated in terms of when that condition is true. Pull a ball out. Okay, so when the statement is now, or when the condition is now evaluated to be false, the statements do not execute. Okay, so again, the general format there at the bottom is while a condition, we do these statements. So it looks a lot like an if statement, right? So if condition, and then you have a colon, and then you tab in, and then you give your statements. Okay. So this is sort of the way that the while loop looks in terms of a flow chart, right? You hit the condition. If it's true, you loop and loop and loop and loop and loop. And then once it's false, you fall out the bottom, and then you continue going through the program. So again, the while loop in terms of a condition-controlled loop, so while some certain thing is true, the key element in a while loop is you have to make it to where it will stop executing. Okay, while balls in basket are greater than 50, print balls are greater than 50. Okay, since I'm not pulling a ball out of that basket, the balls in the basket will always be more than 50, which means the loop goes on forever and ever and ever and ever and ever, right? So in order for a condition-controlled, even a count-controlled loop, especially a while loop, to terminate, to not be an infinite loop, you have to have something inside that loop to make that condition false. Okay, so, while balls in basket is greater than 50, take a ball out of the basket and print, more than 50 balls, right? So then it goes, while it's greater than 50, so we have 52, it says there are more than 50 balls, and then it says pull a ball out, so now we have 51. So this says while greater than 50, now we have 51. It says they're greater than 50, then it pulls a ball out. Now we have 50. While greater than 50, well, 50 is not greater than 50, so now we fall out the bottom. Okay, so that while loop terminates. If we didn't have that pull the ball out, it would go on forever. Okay, now what we mean when we say an iteration, that's just one execution of the body of a loop. Now this whole, while the balls in the basket are greater than 50, the body is print there are more than 50 balls and then subtract a ball. Okay, that's the body of the loop, and we have iterated that one time. Okay, now if we have 52, we're going to iterate a couple times. If we have 70, we're going to iterate a lot more than that, right? Now, there are some different types of loops. There's a pre-test and post-test loop. With a while loop, and most of the loops that we're going to be working on in Python, they are pre-test loops. And what we mean by a pre-test loop is the condition is tested before it does an iteration, right? So if the condition is false, it never, ever executes the statements inside of the while loop, okay? So if you want to make sure that at least one iteration occurs, you have to use a post-test loop. Otherwise, if you want to just test it first and then make the loop, then you do a pretest loop. The while loop is a pretest loop, okay? So it tests the condition before performing the iteration. Okay, so there's a flowchart sort of demonstrating, and I'll show you in Python. Okay, now as I had alluded to earlier, we can create infinite loops. All right, so loops must contain within themselves a way to terminate. If you do not do that, you're going to have an infinite loop, and it just goes on forever and ever and ever and ever and ever and ever. Right. So something inside that while loop must make the condition false. Okay, and I'll actually show you what that looks like. So an infinite loop, again, is a loop that doesn't have a way of stopping, so it just goes forever until the program is interrupted. We have to use Control-C or stop it or whatever. And again, you as a coder are going to do this all the time, so don't feel bad if you create an infinite loop. You're going to create tons of infinite loops. I, as an experienced coder, still create infinite loops every once in a while, and it always occurs when a programmer sort of forgets to include the stop encode within that loop. Okay, so let's go ahead and jump over here to PyCharm. And let's just talk about these while loops. Okay, so the general format that we have in while is we type while, right? And then we have some condition here, right? And then we can execute this stuff, okay? So in order to, I'll just make you a real quick infinite loop here. This is looping. Okay, so I now have while true, print this is looping. Okay, so what that essentially means is while true is forever true, it's going to loop. So that means that will true always be true? Yes, true is always true. Always, always, always. So this means this has no way of terminating, right? So if I go ahead and hit that, boom, it's looping and it's looping and it's looping and it's looping and it's looping, and it will never, ever, 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 ever stop. Okay, because I created an infinite loop. So let's go ahead and do age. Well, let's just say I don't know, class, whatever. It doesn't really matter. So you're a participant of the class. Okay, so if you're a participant of the class, let's go in class. Okay, so now that I've assigned that to a variable, so I have in class assigned to true, now I can actually replace this while as in class, right? Okay, so now we kind of have the same situation, right? But because it's a variable, I have the ability to actually change the value that's stored in class. So just to demonstrate, I'm not changing anything. I just made this in class. I said it's true. And then we're just going to go ahead and run this. Now, obviously, I want you to guess before I hit it. Is it going to be infinite? Is it not going to be infinite? Okay, so let's go ahead and look. Well, look at that. It's an infinite loop, right? And it's an infinite loop because in class never, ever changes to false, right? In class is always true. So in order to actually have a terminating condition, I need to change in class to false. Okay, so now if we read this from the top to bottom, in class is true. So while true, it's going to go ahead and jump into that loop because the condition is true. It's going to say this is looping. Then it's going to set in class to false, which means while in class is now false, which means it's going to stop looping. So we should have exactly one iteration, right? This is looping. Okay, now we can also change that if we want to, and we can make it to where we can have some sort of a user input, right? We can set in class to true. And then we can actually set an input here, right? Input, enter value, right? And I'm going to just use true and false. And I'm going to make it a string just so we can alleviate any errors, okay? So, and actually, no, we're not even going to do that. We're going to just set it to true. I'm going to actually use a bool conversion, and I am going to convert this to true or false. So I'm going to convert it to a Boolean. Okay, so input always spits out a string, and then I'm going to go ahead and convert that to a Boolean. Okay, so we're going to run this. It's going to say this is looping, then it's going to say enter a value. So if I say true, it's going to go ahead and say looping again, right? So if I say true, it's going to loop again. Now, if I say false, it's going to exit. And actually, it didn't end up exiting because it didn't convert that. Let's try this again, see if we can make it kick out of there. Nope, looks like we have an error in our conversion. Nice. So let's go ahead and see if we can fix that. So essentially, we could actually convert this in a different way. Okay, so we can actually say age. Okay, so we're going to enter an age. And then if the age, we're going to use a little thing here. If age, int, age is greater than 10. Okay, so now we know if we do that, then we can set in class to false. Okay, so now we're actually going to change it. It's going to enter age. If it's greater than 10, then it should quit. Okay, so let's try this again. That one didn't work. Not really sure why. Okay, so we're going to go 9. Okay, so 9 is not greater than 10, so it should loop again, right? 2 should loop. 3 should loop. If I go 23, it should quit. Okay, so you see how that actually quit right there? So 23 quit. All right, so that's another way that you can break that. You can also do something really interesting. You can actually have a while loop evaluation here. Okay, so I could do something like count, and we'll all kind of dive into this. So I can say count is 10, or actually I could start count at 0. Okay, and I could actually say while count is less than 10, we loop, right? Okay, so we say this is looping. Okay, now, obviously, with count to 0, 0 is always less than 10 because count never changes, right? But what happens if I do count equals, and we can actually do this count, plus 1, or, as we saw in the last chapter, count plus equals 1. Now we actually have this modification. So the first loop, count is 0. And then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it hits 10, and it's no longer less. So we actually should see this loop. Now, while we're doing this, let's go ahead and actually just print count. All right, so let's run that. And there we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it terminates, right? And I can change that to 20. And we can see the same thing happen. Okay, so to just explain this, I set count to 0. So we start the program, it's 0. First time it says, is count less than 20? It says, well, yes, it is less than 20. So it prints it, and it's 0 right there. Okay, then what it does in this line is it says, well, let's take 0 and add 1. All right, so now count is 1. So it comes back to the top of this while loop, and it says, well, is 1 less than 20? It says, well, yes, 1 is less than 20. So it prints 1. And then it adds 1 plus 1, which is 2. And then it does the same thing. 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6. Until it gets down to 19, it says, is 19 less than 20? It says, yes, it is. So it prints 19. And it says 19 plus 1 and 20. And then it says, is 20 less than 20? It says, no, it's not. And then it falls out the bottom. So to demonstrate that it falls out the bottom here, we can say, this program is terminating. All right, so we can run that. Boom, this program is terminating, counts to 19. Okay, now the cool thing about that is I can actually make that a user input value, right? Enter count. And now I can decide how many loops there are, right? So I can say 5. Oops, enter count, count is less. Oh, it starts at 5, right? So that's not what I want. I want this top one. So actually, we're going to start count at 0. And then we're going to have upper is what we're going to do. Sorry about that. Equals int. And then we're going to have input. And then we're going to say enter upper or enter count. Why don't we say it? Count 2. How about that? All right. So now we're going to check if count is less than upper. There we go. Okay. So now I can determine what that limit is, right? So I can say I want to count up to 20. Okay. So 0 to 19. Okay. So now I can say I want to count up to 100. Boom, 0 to 99. Okay, I can say I want to count up to 1,000. Boom, 0 to 999. I want to count up to 42. There we go, 0 to 41. Okay, so now I establish the count as 0, and then I get a variable from a user, and boom, I have it counting. Okay, so that's sort of a count-controlled and a condition-controlled while loop. So essentially it's while some Boolean expression, either a condition or a comparison, and then you have your tab, which indicates, or your indentation, which indicates the body, the statements, and then once that's done, it'll fall through the bottom. Now you want to avoid the infinite loops, obviously, and the only way you can avoid the infinite loops, and I need you to get this through your head, you have to modify the thing being checked in the Boolean expression. See how I'm changing count here, changing count? That is how I get out of the while loop. Okay, so you need to modify the expression in the body to get rid of your infinite loop. All right, we're going to take a little break. I want you to play around with that, and then I will see you in the next section.